per edition of CFG. Cool. So we have Sudarshanu Yadav with us, and he's been, as we were mentioning in the what do you say, the lobby, right? We have been talking for quite some time, and to get him on board with the meetup and give a talk and everything. He's been also keen to meet us and talk about his journey with JavaScript and front and all together. So I will let him talk about the intro and stuff. But yeah, we are so glad to have you finally, Sudarshanu.
Sudhanshu.
Oh,
yeah.
I'm so sorry, Sudhanshu. Yeah.
Yeah. So yeah, it's very good to be here. And just to give more context, I have been doing this like internal stock. Like I used to do this last year, then paused sometime, and I'm planning to resume it back. And Gopi, and like so this is probably one of the start of it. And today it would not be more of a talk, it would be more of like a session, and let's keep it interactive. We will try to dive more into how the concurrent features, what new things are coming, how it works, why it is needed, and what are the complexities behind it. So we'll talk on that. If like just to give intro like about me, I currently work at Prophecy. I was working previously at HackerRank. Recently switched to Prophecy around May. And I've been doing like a front end from like last 10, actually more than that, from college as well. So yeah, and I'm pretty much into React and also like love to figure out like how things internally works. So we'll see some of those internals on this session. So yeah, we will please if you have any questions during the talk as well, drop it on message. I'll see if I can answer at that moment. So like the session is more interactive rather than just like me speaking, because like I speaking for 1 hour without any interaction, it feels like too much. So we will try to keep it interactive as much as possible. Okay. Let me share. Can you enable sharing my screen?
Sure. Give me a second. Can you try now?
Yeah. Or let me share my whole screen. Okay. Yeah. So people who have been following on this concurrent mode, you must have known that like this has been more than 2 years. Not 2 years, actually 1.5 years. Actually 2 years. So they have released this initial document, and people were like awed after seeing all the examples of it. And they are trying to achieve something great, but at the same time, it's like the number of use case React team has to solve. And even like while I was working on Brahmos, I had to implement the concurrent features. So the number of use cases I had to solve to support those API were a lot. And the way we'll do today is like why we need, first let's see like why we need concurrent features, or like in general, like why we need concurrent mode. So the first thing which I would say is like the pursued experience. So most of this library, I'll not like to take name, but if you see on the trend, we have this thing, right, where framework or library check their JavaScript performance, what is the render performance. While that is necessary, while that should be a good focus, because the underlying engine should be fast. But if those small improvements, or like, let's say if you're saving 10 millisecond or 5 millisecond or something, um, if those improvements are not noticeable by user, then does it matter? Like, uh, people might be doing something in background. Let's say I'm trying to interact on some element, and for some particular thing, it's okay if it is lagged behind. But the main interaction, like if I'm typing in an input, that should feel fast. So uh, those like direct actual performance improvement might not always give a very good user experience. You can have uh, as much as fast engine at the background, but your application can be crappy. So the application should feel smooth to be smooth. It doesn't have to be actually smooth. So that's about like a perceived experience. If user can perceive your application to be smooth, then actually your application looks performant. So concurrent API try to solve that problem. It try to bring that declarative API with which you can build better pursuit experience. So if you must have seen this, right? I'll go through the doc only, but yeah, you must have been seen this, that we have a suspense API. We have suspense right now. Suspense only support for lazy loading your components, but the idea of suspense is mostly like if you're trying to render something, you can suspend in between, you can pause the rendering, and then you can, like, once the data is there, you render it again. So it could be a component, or it could be a data. Like data, you can start loading, and then until it is loaded, suspend your loading, and then again load it back. So this is very declarative part of it, where you can define like what dependencies are there which you want to suspend on, and then while your application is suspended, what is the fallback you want to give, and once the data is loaded, how you want to resume the back. Now earlier it was only for components, but with concurrent feature, it is coming for your data load as well. So in that, basically, I'm not sure if it is a plan of the direct React 18. I think the React 18 right now is just focusing on need to confirm. Probably suspense and yeah, actually suspense and suspense list is also in the plan. So the idea is that where you can define your data dependency in a synchronous looking code, where you can just say, I have some resource, and try to read the resource. And if that resource is not available, just suspend that whole thing, whole render part, and so the fallback. And once this thing is available, then you actually show the particular element. Similarly, so this is one example of a suspense, and in suspense, you can, let's say multiple things are suspending together. You can take an example of you're trying to load an image in Instagram type of a view, where you are trying to load a different image, and you want to render images in a sequence, like you want to render first image, then second, then third, and then so on. So right now, because all of those things are async, and you don't know like when those async thing will be resolved, so people have to manually write a lot of orchestration of how rendering should happen, how you render first image, then you render second image, or like how you handle the rendering sequence, right? So suspense provide a declarative API for that, where you can say, okay, I'm waiting for an image load, or not just image load, you can think of any resource, whether it's a image, whether it's a data, whether it's a script or anything. You basically say like, okay, I'm waiting for something. And whenever it loads, it should load in a sequence. Or let's say if there are two images um, uh, which kind of relate to each other, then those two images should be shown at once instead of showing one and then people get confused like what this image is about, and then the second image loads, so you have some delay. So you probably want to wrap those whole thing into one. And if you try to do that manually, it's like a lot of you have to play with promises, async code, and the problem happens like if you must be aware, right? Recently, React disabled the warning of doing a set state in an unmounted component. So this is a very common thing where people used to try fetch, do this like a fetch user, and then once it is resolved, then set the user. This is a very common use case. But what will happen if the profile page itself is unmounted? It will try to set the state, and that time probably you are doing something which is no longer required. So giving this control on the underlying engine makes things much more controllable. Like React can control how something should load, or how something should set a state or something like that. So yeah, with Suspense API and concurrent feature, you get that capability, that you get a declarative way of defining, uh, first improving the pursuit experience, because you can control the rendering sequence. You can pause your rendering, like suspending rendering, and you can kind of like um, restart whenever your data is there. So all of those capabilities comes from concurrent feature. And um, along with that, so let me just go to different API. Yeah. So along with that, there are cases where you the first example I gave, right, where you want some piece of your application to be fast as possible, and some piece of your application which can lag behind. And this is currently kind of like a possible by manually saying debounce, or doing lazy computation or something. But again, orchestrating that is problem. And you when you apply those things manually, you don't effectively use all the resources available. So you kind of like make an assumption, estimated guess, like after 200 millisecond, probably my user will stop scrolling and then I should execute something. But that assumption might not always be true. So there are a lot of bugs which can happen. There are a lot of like corner cases which can come. And coming like that feature coming directly from the library you use. So it should be a first class support from a library where they can give you API where you can declarative say, this is the portion I don't care about, or it can lag behind. So React is bringing certain APIs for that, where you can say, okay, I have this particular portion where I can defer my value. Like I can keep showing the older value until everything is rendered. So your component might be taking too much time. Actually, we will see that later. But yeah, I'll just to give a hint on that. So we have multiple APIs like deferred value, where you say you want to defer a value, and it's a different than debounce. We'll see how it is different. And similarly, like you can say start a like you must have seen transitions. So basically, if you are setting a state, you can say my application should go from state A to state B, and anything between that transition can lag behind. So you can just mark something as a transition, and that transition will try to get asynchronously rendered. We'll see about like what asynchronous rendering and synchronous rendering means, but just to give an idea about the API. So the main idea of the concurrent mode is to provide you the declarative APIs for pursuit experience. Any question on that part? Any confusion on like why these concurrent features are there? I am not seeing the chat section. So if
I
okay,
think we don't have any
okay,
question yet.
okay, cool. So
I'll keep you posted. Yeah, please go on.
yeah, let's see what all patterns are there which internally um, enables your concurrent features or a concurrent mode. So the first important feature is a time slicing, and this time slicing React introduced with the fiber architecture, and this is a very integral piece of your enabling any concurrent features. Now let's see what it means. So if you think, let's consider this is our React application where you have multiple nodes, and here let's say every node denotes a component, and assume your your component takes some time to render. It might be a slow component, and there might be a valid reason for that to be slow. Now, in a synchronous rendering, how it will happen? So whenever you make change a state on, let's say, on top level component one, it will render the component one, and then because it will render a new children, it will then render their children, and it will synchronously try to render all of those nodes down the hierarchy. Though React will try to figure out what is the difference between previous render and new render and try to apply only the changes to the actual DOM, but the render phase itself, it will try to actually call the component dot render method for a class component, or it will try to call let's say it will try to call your function on a functional component. So it will happen all synchronously. And though React breaks your whole application into two phases, one render phase, and the second is like a commit phase. So in render phase, what it does, it renders all the component one by one from wherever the change has happened, and then it also figure out what is the difference from the previous render and new render. That is basically called reconciliation, React reconciliation. And after that, once React knows what all the changes are there, it commits those changes to the actual DOM. So it happens on a two phase, but still everything is happening synchronously. Now that should be fine for a small example like this, but for an application which is like a big, or let's say you have a chart or you have some complex logic happening around component, then it could be a problem. And sorry, I'm jumping around multiple slides. I didn't created any specific slide, but yeah, I think uh, we can we can understand what is happening around it. So let's see how that plays on our frame timeline. So we have we have a frame, like most of the library try to achieve 60 fps, and what 60 fps means is you get 60 millisecond between every frames. Now in the 16 millisecond, a lot of things has to happen. Your JavaScript task will execute, your browser task will execute, and JavaScript task would be your like actual render method, component render method, and browser task would be basically uh, if you are making any change on your DOM, then finding what all the making the layout change. Internally it creates a layout mapping, right? So it will create a layout tree, or it will create like a style tree, that what all style has to be applied. It will create layers, the composite layers, and then it will the layers, and it will composite those layers. So there are multiple things happening in browser, um, and all of those things are happening to paint some information. If you have typed something, user like a browser has to give that feedback, right? You have typed a on an input, and then whatever you have typed, it should be visible to the user. So all of thing the browser is also doing, and at the same time your JavaScript task is happening. And as you know, like JavaScript is a single threaded. So if you do that, the let's say our whole rendering is a big task. So what will happen if in big task like this, if there is a like a browser task, which could be your painting, layout and everything, or animations, any of those things can come. Now it can't fit in between, and you have if your JavaScript task is spanning across multiple frame, then it has to wait for the whole JavaScript execution to finish. So it will wait for that, and once it is done, it will try to paint it, and you will feel set or like a you will see the frame drops in your application. Like if you type something, your application will feel janky. So the idea of time slicing is, instead of having a big task, you break your task into a smaller pieces. We can call it as a smaller unit of works. And if you have a unit of work, let's say if you have a multiple unit of work, if you have broken your big task into multiple unit of work, now if a browser task comes, it can easily fit in between, and your like application can sync up. And after every executing every unit of task, you give some breathing space for browser, so that browser can do their own job. Now let's try to see like how that time slicing thing works in React application. So the behavior would be, now instead of treating each of this node as a component, now treat each of this node as a unit of work. And React, like Brahmos, will try to try to execute this unit of work at a time. And every after every unit of work, it will check should L2 browser. So L2 browser, and by some logic, like let's say I have a 16 millisecond time frame, and rendering this like a node 1 only took around 1 millisecond. So I still have a lot of time, so I don't need to yield to browser yet. I can keep continuing executing my further task. So it will keep saying like false, and I will keep executing the next unit of work. But as soon as it says like, okay, L2 browser, then what will happen? It will stop the execution. So let's say we processed unit 1 and unit 2. Now the browser, like our method says we should L2 browser. Maybe we L2 browser after 5 millisecond or 10 millisecond. We will see about that scheduling strategy as well. But let's say we yield after some time. So whenever we yield, what it will do, it will stop the execution at that point of time. It will give the control back to the browser task. It will continue the browser task, whatever the task is pending. And once that is done, it will come back and it will process the next fiber. Actually, React called that unit of work as a fiber. So I might call that as well. So yeah, basically the idea is you break your whole big task into a smaller unit of works and execute one by one. And after every unit of work, check whether you need to yield to browser. And if you have to yield, you pause your process at that point of time. You give control back to browser, and then whenever browser is done, you come back. Now, what is happening here is basically like you are turning your synchronous rendering into a asynchronous rendering. And this is very much required because uh, in a synchronous phase, you can't pause in between. Or if you pause, you don't know like where to restart again, right? And basically like whenever you pause, it becomes your like async task. Now there is a problem. So basically like there is a problem with trying to do rendering in the same tree asynchronously. And to solve that, React came up. Actually, it's not like a React pattern. A lot of gaming engine does the same thing. So instead of trying to render on your application like a main tree, you create a new tree, which we call it as a, like a, let's say we call this as a current tree. And your current tree is a representation of your actual DOM. Whatever you see on a DOM, all the states are consistent with that. But if you are making any change on your node 1, then if you try to render on the same current tree, and if you pause in between, what can happen while this while you have paused, your tree has become inconsistent with your actual tree. And at the same time, while you are paused, let's say another set state came. Now there could be a conflict, like you might have the first set state have changed some state, and then the second set state came, and they conflict with each other. So basically, if you make your correct data structure, if you like mutate it, if you make it dirty, then it's harder to roll back. And to basically to roll back, the next like pattern, which is background rendering. And in background rendering, what it does, instead of trying to rendering on the same tree, it creates a work in progress tree. So let's say my state change happened on node 1. So what I would do, instead of doing here, I'll create a new work in progress tree. In work in progress tree, I'll copy that particular unit of work, or let's say fiber. And in that fiber, if there is any updates, pending update, which is set state here, so I'll execute that particular thing, and basically call the render method. And with the render method, now I will get a new children. So I'll compare that new children with the existing children in the current tree. And if I find like the children's are same, maybe only some properties are changed, some attributes are changed, or some like a text content is changed. If the elements are same, what I can do, I can just copy those fibers, like a clone those fiber from my current tree to work in progress tree. Now I'll keep doing this. The next process of unit would be it's a direct children. So second, it will go on a second. It will see is there any pending update. And though it doesn't have any set state, but because it is a children which is rendered from 1. And if I have done some react.memo, or let's say component should mount. If I said like component should update, should component update as a false, or react memo in the React memo, the dependency doesn't change, then it will not go in this path. It will not go in a second path. And because I have cloned this second uh, fiber from the actual fiber, the current tree, it will have the reference of the previous nodes as well. So while I'm cloning, it will have a reference of 4 and 5. It's just that we don't care about it right now, but it will have that reference. But let's say I have to render it, I'll render it, and again the same step will happen, that the new rendered children will compare with the children with the like a current tree. If they are same, clone it. If there is a change, then you create a new fiber, and at the end you will end up creating a new, like a whole work in progress tree, which is a new correct representation of an actual DOM. Now, all the updates has happened here. It is not yet committed to the DOM, but this is a place where all the updates are happening. With this, what benefit you're getting? Let's say in my work in progress tree, I have come only till 2. And for some reason, I have to yield to browser. I have to pause the execution. At that moment, if there is a new set state happening on my node 1. Now, the simple thing I can do is, like, because I haven't changed anything on my current tree, I can just dump my previous work in progress tree and start fresh. Or let's say the state change is happening on node 4, and I already executed 1 and 2. So I can reuse some of my pieces, because 1 and 2 will still be same. The work done on 1 and 2 remains, like I don't have to throw it up. But while I'm executing 4, at that point of time, I will have some pending updates, and based on that pending update, I will call render method. So basically that is the idea. You can pause and you can come back, you can change anything there. And if something happens which is like a breaking in nature, you just throw away your actual like work in progress tree, or you can resume back on your work in progress tree, based on where you are making those restrictions. In a React, it's a little bit different. So React always, like, let's say it doesn't actually throw the whole process, but it will try to reuse this fiber. So no garbage collection takes in place. But what it will do, it will again start from the start. Even if I made change on a 4, and it has a process till 2, it will again start with 1 only, and it will again process that pending update which was there when I made my first state change. So React does that. In Brahmos, I went on a different approach, where I try to reuse the work done, previously work done. So there is a slight difference there. Now, that is basically background rendering. You try to render something in a background. You don't touch your main code. Now, that's one pattern. The third, and basically that is also like an interruptible rendering, because now you can interrupt while the background rendering is happening. You can interrupt some high priority thing, can interrupt your rendering, and then it can restart it. So with this, basically all those capabilities, right? Suspense mode, all the suspense APIs, suspense for data fetching and everything, all of this are possible because of those background rendering. Now, the third pattern is basically pattern. Actually, it's a more of a concept. Is a eventual consistency. Now, let's say I have a UI, something like this. I have one input, and here I'm showing some chart. what's here. Or actually, let me see if I can find that example. This is one good thing to demonstrate. Okay, so in this example, all of this component, like all of this list item, have some delay. Like let's say this list render a little bit slow. Now, when I am trying, like this is basically not without concurrent mode. So if my element is slow and I'm trying to type something, the input feedback is slow, and that is because like I'm trying to render everything synchronously, and because everything runs on a one main thread, it blocks my uh, painting, and the input value need to be painted by the browser. So this is a problem. Now let me see with a deferred value. So while it load, okay. Uh, Basically, eventual consistency, it means you break your application into multiple parts and say this this two part of application can go out of sync, and you intentionally say that. And actually, I don't know why this is not loading. Okay, but let me try to explain from here. So basically, you say your input change is a high priority update, and users should get a feedback of any change happening in this. But this list, it's okay if it lags behind. If I'm typing something, it's not that my focus, like a user focus, is on this list value, and if it takes a little bit more time to render, it's fine. But I should see this value as soon as possible. So I have a two type of updates here. One is a high priority update, where user want to see the effect of whatever they are doing as soon as possible. And then there is a low priority update, where it's okay if it lags a little bit behind. I think that they have some problem on their demo. Or actually, let me try to open Brahmo's demo. I have implemented. Uh, don't say code sandbox. Oh, okay, cool, nice. Um, okay. So here, basically what I'm saying, like when I type, the feedback should be fast here, but you can see like the bottom section is little bit lagging behind, but eventually uh, it gets consistent with whatever I have typed. So the idea is that you can manually say this is a part of application which can become inconsistent for some duration, and make it consistent as soon as possible. Um, and how you achieve this is basically like there is a uh, use deferred API right now, where you say okay, I have to show the text as soon as possible, but I have some deferred text which can basically lag behind, and it's a different from debounce. Um, in this example, uh, in this example, if I have used debounce, what would have happened that as soon as I stop typing, my rendering will kick in and it will try to render my elements. Now, while it is trying to render, uh, debouncing is like a delaying your problem. It's not actually solving the problem. It just delays the problem after some millisecond. So if I do that and I took a 100 millisecond pause or 200 millisecond pause, my application starts rendering the slow list, and while it is rendering, I started typing. So if I type at that moment, then again the same problem will remain, that I'll see some frame drops. So with this deferred rendering, what we are doing is, instead of debouncing something, we are deferring a rendering. And deferring a rendering is saying that try to render as soon as possible, but it's okay to lag behind. And so React or Brahmos here, they will try as soon as you're typing, but okay, let me come back. So you will see for first few characters, the changes on this list happen as much as fast as possible. Like while I'm typing, I can see all the updates. But as soon as I grow my length, what the logic here is like, the more the length is, the more items I add in my list. So basically there is a more work for the library to do. Now, while my character length is increasing, you are seeing the thing is lagging. So for a smaller character, it is displaying the result as soon as possible. For longer character, it is lagging a little bit. So basically it is adjusting your rendering based on how much time your application is taking. It's not like a debouncing something. If something had happened fast, if I am using like a powerful machine, probably for this long character as well, I don't have to wait. And the feedback rendering list will happen as soon as possible. But for if I'm using like some Intel 3 or Intel Pentium core type of processor, that time it might lag more behind. But at the end, everything will get consistent. So this is effectively using the resources, and um, and everything is handled on your library level. So you don't have to manually write logic behind it. You don't have to figure out like whether it's a low end CPU, then have a debounce value a little bit bigger, or if it is a high end CPU, then keep the debounce value smaller. You don't do that, and it's not a good idea to do that as well. So let you just tell the intention that I want to render something which can lag behind, and let the library decide how it want to present it on actual DOM. Whether it's shows directly, for fast it shows directly, for a slow system it lags a little bit behind. So that is a idea around it. Yeah, so I think I have someone has a doubt.
Sudhanshu, yeah. So please bear with me if it is a very silly question. So I'm not a front-end guy at all. But when you talk about deferred value or deferred rendering, right? Let's say in this case we have around 200, roughly 200 and some elements are being rendered as soon as we start typing, right? Or whatever the number could be. So my question is like, behind the screen, it's all like all the call stack, and I remember this event loop stuff. So let's say, how does the library identify, or what is the actual scene behind? So when you say that eventual consistency is propagated, let's say user is typing, and the library somehow says, please hold on, because we this is the more important or prioritized task. Then the moment user stops, the rest of the elements will start rendering, right? Again, when you were explaining about the bounds, right? How even when the user starts typing, the rendering has to be paused, right? So how that is actually done behind the screen, is that the sequential, because if I'm not wrong, again, it is a single threaded, right?
Yes,
It
yes,
would have been scheduled to be rendered, and if the user start typing, that has to be prioritized somehow in the queue.
yes.
And how, could you
Uh,
please more
yeah, yeah, sure.
add more light? Yeah.
Yeah, yeah, sure. So let's try to run that example in this tree. So for example, we have this component where I'm making a state change, and that is like a input value change. Now, basically with the deferred rendering, or like this background rendering, what we are doing is, instead of trying to render in that tree, we are rendering in a work in progress tree. Now, um, whenever a deferred, like a, let's say when you're trying to render a list, what is happening? When you type, it will start processing it on a work in progress state. It will try to process it until it's done. And but as soon as you interrupt it, how you interrupt it is by setting another state. So you set another state, and in this example, we have a two type of state. One is like the state which has to be applied synchronously, which has to be visible on an input, and the second type of state is a deferred state. Okay, so I made some high priority update here, and I'm saying like this high priority has to flush synchronously. Now what will happen while the React is busy in trying to render the list item? If any other update happen, it will throw the work. Actually, it will pause the work, and it will restart with this new state. Let me know if I'm not making any sense.
Yeah, you're making.
Yeah.
Yeah,
So
thanks.
the rendering is happening. So
Okay.
as soon as the deferred rendering, we call something is the rendering is happening in a deferred way. It means the rendering is happening in the background,
Okay.
and that rendering is happening in the work in progress state. But if I interrupt it with another set state,
Mhm.
it will throw the, like, it will stop the previous rendering, and it will start fresh.
Oh,
So
kind
that's
of
why, like,
temporal. So it will start again when it gets time. It has to start from the fresh.
yes, yes. So
Okay.
we'll see this when I'm typing here.
Mhm.
Well, I just typed k. Now what happened? There are two type of state. The first synchronous state, and for the synchronous state, it went to work in progress state, and it updated my input value, and it was very fast because only the input has to be updated. So the whole work in progress tree render and commit phase was quite fast. The second phase is basically like trying to render my deferred value. So it will again come to this work in progress tree. It will try to render the deferred value. Now, uh, when I typed only one character, the system is fast enough. It is able to process all the nodes before I type another, like another character. Because in this example, I have only 5 items, and even though it is taking like a 5 millisecond, each of this list item has a 5 millisecond delay. So even it is taking 25 millisecond, what is happening? There is some delay between user interaction, right? I might be taking 25 millisecond time for typing the next character. If my rendering is finishing before that 25 millisecond, then I don't have to throw the previous render. I can directly show that. But let's say if the character increased, Now I'm rendering 50 items. 50 items is basically 250 millisecond. Actually, it is not 5 millisecond. It could need to check in the example. Deferred. It is 1.5 millisecond. So each of this element is 1.5 millisecond. So 50 items basically means around 75 millisecond. If I'm a slow typer, if I take more than 75 millisecond to type next character, then the library doesn't have to throw the previous render. It can render it. So basically, like it automatically adjusts based on how frequently you are interacting with your application, plus how fast your system is. That 1.5 millisecond I manually added, but in a real world use cases, it would depend on different type of system. Like the faster CPU will process a fiber in less millisecond, and slow system will process that particular fiber in more milliseconds. So basically, it is just like everything try on a background tree, work in progress tree, and if some other update happen, start fresh. Hope that clears.
Yeah, it is. Thank you.
I know the working of suspense. Can you tell more on it? Sure. So we can do this in this way. Suspense have multiple APIs on like a rendering sequence. You can define the order of rendering. You can define like two updates should be batched together. So try to visualize everything with this work in progress team. Now, whenever you write a suspense and whenever you suspend, what is actually happening? It tries to render in the work in progress stream. And whenever it suspends, let's say on the second node, I suspended my rendering and I went to fallback state. Now fallback state is a new state, right? So it will again try to render it on the work in progress state with the fallback value. So instead of 2, maybe I will be saying some fallback. So because everything is happening in a work in progress state, your actual DOM doesn't get affected by it. And that's how like a suspending works. And now let's think about how the batching thing works. So let's say my node 2 and 3 both are suspended, and that will resolve based on some promise 1, promise 1, and promise 2. Now React internally knows that which all node has suspended. So how it will work? First, it will try to render the second node. It will suspend and it will have one promise attached in its internal life cycle. We will not go on to that. It will take like a lot of time. But yeah, let's say React internally is holding this promise 1 somewhere. Now with that fallback state, it will start trying to re-render again. So it went again on a node 1. It tried to re-render a fallback state here, and it will next come to my component 3. In in the node 3, again it got suspended. So now there are 2 promises. So again React will go here. 1, it will try to render, and it will so 2 is already suspended, so it will show the fallback for the 2, and 3 is also suspended now, so it will show the fallback for 3. Actually now by showing the fallback, it's not like actually showing the DOM. It's just finding what all the fallback is required to be visible on the DOM. React hasn't made any change on the actual DOM yet because it's still in the rendering phase. And once it knows that okay, this is something which I have to commit. Now these two things are suspended together. What it would do, instead of like a in a synchronous rendering, how it have worked, when I got suspended on node 2, it will show a loader for let's say second node, and then you will see one loader, and then it will again try to re-render it, and then you will see a second loader in your tree, right? So instead of doing that, what React does, it try to batches things together. So now two things are suspended. Instead of showing two loaders at two different time, and whenever you are showing two things on a two different frame, you will usually feel like there is some bad thing happening, like some flickery type of behavior. You will see like every time you will be repainting and relayouting, right? So it will try to merge that. Now with the suspense API, what it also support, let's say this two belongs to one suspense list. So let's go to API suspense list. So the same example, consider it as a 2 and consider this as a 3. Both are wrapped inside one suspense list. Basically, your declarative telling React that this 2 suspense belongs to one list. And in this, you are saying like whenever the suspense is resolve them in a forward order. Basically, forward order, it means first show the value of, if it is an image, so first show the first image and then show the second image. Even though my second image is loaded first and this suspense is resolved before the resolution of the previous suspense, but it will wait until this is shown to the user. Now along with that, what will happen, let's say there is a delay of I'm loading image 1 and image 2 on both of these suspense, and both of image got loaded in a 20 millisecond difference. In that case, it will not try to render like a first element and then second element. It will try to batch it together. So basically React calls it as a reveal train. How it works, it will have something called a time frame of a 50, let's say 50 millisecond. Now any suspense getting resolving on this time frame will be revealed together at this point of time. But if one of my suspense is getting resolved in this time frame and the another suspense got resolved on the another time frame, then it will be rendered in the order you have defined. Like if you have said forward order, then it will render in a forward order. If you have said backward order, it will render it in a backward order. So basically React internally have all the references, where I go, sorry, React internally have all the references of the suspended values, and to simplify it, we just say like it's a promise, and React can decide like based on what suspense list order you have given. If you have given let's say forward, then it would be something like this, promise 1, then promise 2. Even to my promise to get resolved first, it will have to wait for promise 1 to get resolved. So basically it can decide, and if you have given backward, this will become 1 and something like this. And if you have given reveal order as a together is basically you're saying this two suspense should get revealed together. So basically what will happen in this case, it will create a promise.all and then do promise 1, I'll just say p1 and p2. Okay. So in this case, basically we are saying like resolve once all is done. It is more complex than just promises because you have to manage states while resolving this. But to visualize it, you can think it as a promise. Like every suspension is a promise, and based on how you have defined the order, those promises are layout. Like they are they follow a different pattern. Hope that answers the questions.
Yes, bro, it's very clear.
Cool. Okay. Coming back to where I was. Okay. Coming back to the last pattern, which is the transitions. And transition is basically saying transitions. So transition, if you have been following React, you know, like you have some API coming called use transition, and you can import start transition in React 18, the new 18. You can directly import it from top level import. But the idea is whenever you do this hook based thing, it will have a different instance of a transition, and if you import from like a global, it will have a global transition. And what happens in a transition is any state you are changing in that transition. Now you might call, let's say, some callback, which is controlled from a parent component. So all of those state updates are merged together in one transition. And transition is just saying like declarative, saying that all of my state updates have to happen together, and that update can happen in a deferred way. So we saw that use deferred, right? It is very similar to use deferred, but with a use deferred, you are just saying like uh, I have a value and I have a deferred value, and in this transition, it's a different way of telling the same thing. Is that um, all the state updates within a transitions are a deferred value, and also along with the deferred value, they belongs to one transition. So it will never happen that one of the state is rendered first and then the next state is rendered. So if I'm calling, let's say, if I'm doing something like this, set resource 2, now this 2 state has to be flushed together to the actual DOM. It will never happen that it will just render the first state and then it will render the second state. So, this is where it differs from use deferred value. In deferred value, all those deferred value are independent to each other. If you are having a multiple deferred value, it will try to render whatever deferred value gets resolved first. In a transition, you say like all things are binded together. Okay, so that both are same, and in transition as well, you will trigger a deferred rendering instead of like a synchronous rendering. And in a transition, you can also provide a timeout. Let's say, so we saw here, right?
Bro, sorry to interrupt. I have one doubt.
Mm-hmm.
People in React, I have heard that React will update the state if it is not a, it is not a asynchronous activity, means it will patch all the state updates with one patch and update all activity.
Mm-hmm. Mm-hmm.
But if you are trying to update any asynchronous activity, means it will first update the synchronous activity first, then update the asynchronous activity. This is the process of React. While using use transition, we can also is it possible to update the asynchronous activity also, like asynchronous in a synchronous way?
Ideally, you shouldn't do that. So I think you are saying is this do set timeout. You are saying something like this, right?
Yes.
You can. Nothing will stop you doing this. And in this case, it will not belong to one transition.
Yes,
Because
that's
this just like a you manually saying that start this transition in this timeout. So here you are breaking the transition cycle.
Okay.
Okay.
Yeah.
But you are correct on that part. That with React 18, now also they try to merge all the state updates, all the synchronous states, but that's not always the case. There are some corner cases. Automatic batching doesn't happen always. With React 18, automatic batching will happen every time. If you don't have a, let's say, start transition, if you're just doing like this in previous, like a current React, what can happen if it is happening within one component, then it will try to batch it together. But let's say if my set resource 2 is happening on a parent level component and I'm calling some callback here, then there are some cases where the batching will not happen. That is a behavior of React 17. With the React 18, all the update within an event will happen together. Unless you manually say like a set timeout or something. Unless you do that, everything will be batched together.
Okay, bro. Okay.
Yeah. So yeah, coming back to transition. In transition, we are saying like you do a deferred rendering, and in deferred rendering, what we saw is that this deferred rendering can be interrupted by high priority updates. Now, what will happen if I'm trying to render something and it is taking so much of time that and I'm running like a high priority update in a request animation frame, and which is happening every 16 millisecond, and my whole like application rendering work in progress tree rendering takes more than 16 millisecond. So in for such cases, we have a concept called timeouts, where you can say like okay, beyond this time, like if you reach this timeout, then mark this transition as a synchronous rendering. So basically like you move the deferred rendered transitions to a synchronous rendered transition, so that everything will if this timeout happens, then it will be flushed at that point of time. Okay, so that's a transition, and with the transition you can do a lot of crazy stuffs, like you can start multiple transitions. You can do something like this start transition to you can call like you can have a nested transitions. So there are a lot of corner cases with this, and that's why like the whole concurrent feature is taking so much of time to bring up, because in user land people can do all this nesty stuff, and this will break the nesty cycle. And even you told, right, what will happen if I do a set timeout, what should be the behavior. So making some default assumptions about transitions are a little bit difficult. To simplify that, what it does, like right now React is simplifying it a lot, but in future they will have a different concept. Let's say if I am updating two different resources here. In first transition I'm updating resource 1, and in second transition I'm updating resource 2. Then this two transition will happen independently. They don't have to block each other. React has simplified it right now, because like it doesn't know that you are trying to affect the same thing. So it try to merge all the transitions together, and it will always merge whenever let's say I'm trying to update the same state. in two different transitions, then it will merge these two transitions together. And whatever the lower timeout value is, it will take care, like it will respect that. But the idea on a long term is that every transition will run on their own, you can say, own universe. They don't have to interfere with each other. And cases like this, probably they will provide some lint thing, or they will try to figure out, like probably they could continue doing the same thing. If you're trying to update the same value in a transition, then probably it makes sense to merge them to not have the inconsistent state. Or you can manually say, like this transition I want to run in a different, no matter I'm no matter I'm updating the same state. So probably in future you'll have such APIs, but for now they have simplified, like transition they will try to batch together. But yeah, the long-term idea is to run this transition in their own universe. Okay, so that's transition. Now let's talk a little bit about the complexities. Like why what are the complexities in this whole process. The first complexity is like you state sync between this two trees. Now, as I mentioned, you can be doing some background rendering, and at the same time some high priority update can make a state change. So right now React try to simplify it by saying, okay, any update, whether it is a synchronous update or asynchronous update, try to do it on a work in progress stream only. So if there is a high priority update, ignore the low priority update. Like so basically it has divided into two type of update: synchronous and deferred update. And synchronous update, it will always do first, and then it will continue with the deferred update. So you first you pause the deferred update, you continue the synchronous update. Now what happens with that? There could be a chance where a deferred update and a synchronous update are trying to update same state. Okay, while my deferred update is in progress, there could be it's very much feasible that a sync update can make a change on the same state. Now once you have done the synchronous update, like always you will prioritize the synchronous update first, then you will go back to deferred update. Right now, how you will know that this state is correct or it has become stale? So you need to sync your new states to the deferred update. So what it even in React, it does something similar, and even in Brahmos, I'm doing something similar. Basically have a timestamp, and which says like for the latest update, it will have the latest time stamp. So always take the state which has the more like a current timestamp, and ignore the stale one. So basically, like you compare every time you have a two state, one sync state and one deferred state. Try to see which one is the latest. If deferred state is latest, then use that deferred state. If sync state is latest, swap the sync state to deferred state. So that will happen while you are doing the deferred rendering. Okay. And the other type of problem happens. What if, let's take an example of a class component. So in a class component, you must be doing something like this, right? A set state, and you pass some value, a:2, and probably you are doing inside a transition, you are doing a:3. So let's do this. This is inside a transition. So it is happening in a deferred way, but at that moment of time, some sync update happened and it updated it to 2. Now, both of them will try to update the same state object. And this state object is a reference, right? And this state object, you will have a reference on your DOM, not DOM, basically your render methods or any of this. So both of deferred update and those things are trying to do it on a same reference. And this could be a problem because it will not be a problem in case of this, where a deferred update is interrupted by a sync update, because now this sync update value is a latest one. But it could be a problem when it happened between two deferred state. Deferred. So let's say I have some asynchronous method in fetch API. I'm setting some state, and while my first deferred state is rendering, I change my state to 2. Now what should happen? Should I cancel the first state update, or what should happen? So whenever such thing happens, first deferred state can be interrupted by another deferred state. Whenever this kind of thing happens, when it try to update the same state, it will try to again re-render from the start, from the top. That is one thing. The second thing is these state updates are not directly updated on my this dot set state. So that's why you must have seen if you do this dot set state, and in the next line, if you try to console log this dot state, it might have the previous value, because this is async in nature. And what do you mean by async updates is basically it will not make the reference change at that moment. It will create a queue of all the updates. So it will just create a queue of A:2, and let's say if I'm having some other thing B:3, it will just keep a list of my updates in a different place. And whenever I'm trying to render that component, only at that point of time will go through this list and try to update this state, because you need while you're trying to render the component, you need the latest value of a state. Your render method might be accessing this, right? So during a render phase, you might need this. But as I mentioned, in a deferred update, thing can happen in an asynchronous way. So that's why even states are not set in a synchronous manner. Instead, states, all the updates are held in a list of updates, and only during the render phase, it will pick those updates and it will apply on actual reference. This is clear, right? So that's why this thing doesn't work. When you set a state, you can't get it here, and you have to provide a callback. It's not something like it try to batch things together. Batching is a independent of this concept. This is just because the updates are not happening at that moment of time. Updates are happening during the render phase. During whenever you change a state, at that time you are just saying this is the state I want to update, and you are just keeping it. You don't actually update it at that moment of time. Okay. So that's why you can mitigate some of those state sync issues. And this I have already mentioned, high priority update can interrupt low priority update very frequently. So there could be a update starvation, where I shown, right, you are doing some deferred state, and you are something happening in request and information fed, which need to be flushed synchronously. So that will always interrupt your transition or like a deferred state. So that's why React provide this timeout strategy where you can mark a deferred state to have a timeout, and whenever that timeout happens, you say like, okay, I want to flush this. Um, in actually in even React does this. Actually, I will mention that on a scheduling concept. But yeah, like it's not that just the timeout which solves this problem. If if a update is taking so many retries, basically like you interrupting a update, if you interrupted an update for let's say 20 times, the value can change for different different cases depending on the type of update. But just to give an example, if the retry of that particular deferred update is around 20, then what it will do, it will start allocating more time for deferred update to complete, instead of keeping it on a same state, like giving the same amount of time, and it going like it always getting interrupted. You will start giving it more time. We'll see it on a scheduler. Okay. This is basically like based on different type of update. React try to figure out. Actually, with React 18, they have simplified it a lot, and they are not doing a lot of heuristic. They will be doing some heuristic on partial hydration, but will not go on a partial hydration concept. It will take a good amount of time to explain that. Let's talk a little bit about scheduling. So we saw that how this update happens. Basically, you process a unit of fiber, you check whether you should yield to browser, and if you think you need to yield to browser, you pause your rendering and you schedule your task after the browser is done. Now, the bigger problem is in this time frame. How do you know that how much time this browser task will take? It doesn't have any idea, right? Like the JavaScript can't have any idea about that. Also, you don't know like how, at what point of time you should yield to browser. If you yield, so this is the problem. Like let me go here. So there comes a fight of faster execution versus responsiveness. So if you yield to browser too less, then your JS will run fast, but the browser will become unresponsive for that duration. But the end output is basically like your execution is happening fast, the overall time is less. And if you yield too much to browser, that could be a period where you yield to a browser and browser has nothing to do on that moment. It is just that like you yield to browser, but browser will not do anything. And because you can't guess like a browser has something to do or not, or you even can't say like how much time it will take. So you probably have some duration, like give some breathing space for some millisecond or something like that. So if you do that, there will be a time where you will not be utilizing your resources. So basically, but your application will remain responsive because you are yielding to browser a lot. But the overall time for execution will increase, and this will make your application slow. So how to solve this, like in a better way, is basically by scheduling things in a more gauged way. So you try to figure out when to schedule, and there are different ways to schedule as well. Like you can use set timeout, you can use a request idle callback, you can use like a request animation frame. There are different approach to schedule. So in BrahMos, let me tell you like in BrahMos how I try to solve it. after every unit of, so basically like instead of yielding to browser every time, I created something called slots. And slots would be something similar, like I have, let's say this is my frame, not frame, this is my frame, and I have a slots of 5 milliseconds. Okay, so basically if browser has nothing to do, probably I can run 3 slots in a frame. And in this slot, I don't have to yield to browser. And React does something similar, but they have a different approach of doing this slot thing. But yeah, the idea is similar. So in this slot, I don't have to yield to browser. In this 5 millisecond, I can keep continuing, because like even after 5 millisecond, if I yield to browser, and browser still have a time to paint for a frame, so user will not notice it. Even though like there could be 120, people might be running into 120 FPS, and the time can remain reduced, but 120 FPS is also something very fast, right? And 60 FPS is good enough to achieve. Now this slot of 5 millisecond came out of heuristic, like a Wi-Fi, because basically like you can have 3 slots in a frame. So after every slot, in a slot, try to run everything one by one, like don't yield to browser, try to process all the fibers in this slot. And after that slot is done, you yield to browser and schedule through message channel. And there are actually multiple way to schedule. And this is one like a hacky way to schedule, but this does the job better. Why? Because message channel are on a priority lane. You can say like when you schedule, the scheduled task also have a different type of priorities, like set timeout with question, does set timeout with 0 millisecond it means that it will execute in 0 millisecond?
Obviously, no.
Yes, obviously no. The simple and actually the clamp is around 4 millisecond in most of the browser, so it will have at least a 4 millisecond delay if you try to schedule with a set amount. Similarly, like a promise resolve, this schedule in a actually I will it will I'll stretch a lot if I will go on each of this. But yeah, promise happens in a micro task queue, and here also you can block the main thread with micro task. So promises are also not way. Animation frame scheduling is not very optimal, because like it happens just before frame has to paint, and there is a good amount of delay if you schedule with this. So the message channel is something like a the delay is short, the delay is like negligible, close to 0 millisecond, but at the same time you yield to browser as well. Like if a browser has a task, it can do something, but there is a problem. So because message channel has a higher priority, and some of the browser tasks are also scheduled. Now there could be a conflict between this message channel schedule and the browser schedule. So maybe message channel schedule might take a higher priority than browser schedule, and browser you can again get into that zone where your browser seems unresponsive. So the idea is that whenever you are close to frame, so instead of, let's say I'm close to frame, instead of scheduling through message channel, schedule using request animation frame, and also with set timeout. Not request animation frame, sorry, request idle callback, RIC, and set timeout. And whichever response first. So in case, let's say browser doesn't have to do request animation, request idle callback will respond first. But in cases where sometimes request idle callback takes more time than it should, so it is not always convenient. So like you fall back to set timeout, and whichever response first, you ignore this the other one. actually I can show that piece of code. Hey, I hope I am not taking more time than scheduled. I thought of 1.5 hours, but yeah, it took more than that.
Yeah, no problem.
Okay. Anyway, we don't have a lot to cover. This scheduling part is the last, and then we can open for questions. So
yeah, you can take another 15 minutes. The second speaker generously gave his time for that. So.
Yeah, sure. Okay, so you can see like in Brahmos what I'm doing. Like if it is close to frame end, then instead of scheduling through message channel, we schedule with set amount and request idle callback, and whichever happens first, let's say set amount happen first, we cancel the other one, and if it is not close to frame, then we schedule with the message channel. So this is basically like giving a space, and this slot even. So I mentioned like a slot is of a 5 millisecond, right? The slot can even the size of slot is not fixed. The size can increase or decrease. How it can increase or decrease is basically like let's say I'm close to a frame and I have only 3 millisecond uh, remaining here. So in this 3 millisecond, instead of creating a slot of 5 millisecond, I'll just create a slot of 2 millisecond. So I still have a breather of 1 millisecond. And in that 2 millisecond, I will execute something. So the slot size can decrease. And at the same time, slot size can increase. And how when the slot size increases is when you are doing the deferred update. Like let's say the number of retry for a deferred update is increasing, then you will slowly start increasing the slot size so that more thing can happen synchronously. And basically I saw this example, right? This one. So this box will become bigger, and this when this box is becoming bigger, my execution time reduces. So basically this it can goes till where is, okay. So it can go up to 30 uh, 30 size of 30, and size of 30 is basically like you can do a frame drop up to 30 fps, and it's fine. Like a lot of games run on a 30 fps and user don't notice it. So in a case where your deferred update is taking too much of time and too many retries has happened, it's okay to drop your frame for up to 30 fps, and it will happen for slower machine, like a low end machine. For a higher end machine, it might run always on a 60 fps. So basically the idea is you can you can adjust this fps based on your device capability. You don't have to give a fixed timing saying like, okay, take this much time to execute. You can basically adjust that. So that's the schedule thing what I followed on Brahmos. React also uses message channel, and they have similar like a frame concept, like a, and the funny thing is like you can't know like when the frame ends, so you have to make a guess type of thing. So how you make a guess is basically like a, instead of basically you assign one request animation frame. Actually, let me show that code. Okay, so you figure out what was the first frame time based on your request animation frame, and whatever the time was there, you can keep adding 16 millisecond on that, and you can think, okay, this is my this is the frame time on my frame timeline. Like this is the place where a frame has to paint, and this is just an estimated guess. It's not always true, but the side effect of doing that is just like you will have a one frame drop on the start of render, maximum you will have one frame drop, but you will not have more than one frame drop. So the side effect of that is like you can have one frame drop on the start of your whole rendering phase, which is fine, and it will not always happen. If your execution happens fast, you will not have any frame drops, but if your execution is taking time, then probably you might have that one frame drop on very start, which is okay. It's a trade-off. So and by the way, like a browser is trying to provide a better way to figure out when there is like a browser has to do something. So there is a API coming called is input pending. Is input pending. In this input pending, basically whenever you call and if there is something which browser has to do, then it will return true. So you can use this on your scheduler API. You don't have to make an estimated guess. Like right now we are doing through frame, right? We are trying to guess when the frame will end. You don't have to guess that. You can just use that is input pending, but it's not supported on our browser yet. It's on Chrome, like they're trying to bring it on all the browsers. The second API which browser is bringing, the scheduler API. So basically with the scheduler API, you can say, this is my low priority update, this is my high priority update, and browser will internally takes care of scheduling. So you don't have to build your own scheduler. Browser will provide you a scheduler API, and you can just tell like what type of update it is, high priority or low priority. So yeah, that's I think that's all. I think I have already covered with this transition part. So okay, we have 5 minutes, please. Sorry for eating up too much of time, but yeah, if you have any questions, please ask. Yes, Gupta, you said no. No for okay. You can unmute yourself and ask, like, or we can wrap it up.
Sorry, my mic had some issue, guys. Again, yes. Would you like to ask any questions?
Bro, actually, I have one common doubt.
Yeah.
In your company, you people are using BrahMos or React?
BrahMos is more of like my
brain chill.
Pet project. We can't use it on production yet. So yeah, we are using React only.
Okay.
But another, sorry, go on.
Yeah, please go.
Yeah, on a different note, right? If you have any roadmap or something like that, you can show, keep share. I mean, you can share with this meetup, and you can ask volunteers to participate if somebody interested as well, so that your pet project can get more fuel, or more hands, if at all, if you'd like to add more support.
So currently it's on a paused state. I for some other practice I have paused it, but when I started back, probably I would be looking for more contributors. But yeah, like at least for some time, at least for a few months, I'm not very sure like I'll have a bandwidth to resume it back. But at the same time, I am doing a lot of other cool stuff. If you are interested to follow that, and if you want to contribute on it, so I'm exploring into this perceived experience thing, where like trying to figure out how we can optimize. So one library I recently posted was optimistic state. How we can track the pursued experience, and how we can improve the pursued experience instead of just focusing on the actual performance. So you probably can, if you have any idea, you can put it as a RFC. We can discuss on that. I'm very happy. Like I'll definitely take this thing as a priority, because like I'm also exploring into it. But yeah, if you have any idea and if you think that's can be done, put it as a RFC, and we can have a discussions around it. Or there are 2 RFCs already. You can just read that. You give your thoughts. Yeah.
Yeah, that works.
But sorry for disappointing that I have paused the Brahmas. But yeah, like
No, not at all. As far as from my perspective, right? You've been doing a lot of re-rendering or rewriting concepts which are already in the existing frameworks, and you're trying to adjust things, right? So these would be nice learning for folks, who's participating here as well.
Yeah, I'll definitely be doing.
Yeah, and no hurries. I'm just saying, if at all you need an additional support, please feel free to, or it need not to be always writing code, right? You can always ask these folks for you to do a testing or whatever it means. After all, it is a Hacktoberfest, right? Hacktoberfest or whatever. I thought like I can, make you as a mentor for a few folks. Anyways, definitely a lot of things going around. People like you making the web better, I would say. Please go ahead and the Telegram group, right? If you want any help, you can find help here as well sometimes.
Yeah. Please share me that as well. I'll join that. Actually, I'm not very active on Telegram, but uh, Discord, is there any Discord channel as well?
Yes, we did had. I mean, it's like there are so many mediums, so we discontinued. It's still inactive, I would say. Anyways, we are still active on Telegram. Twitter as well. Telegram and Twitter. So I'll share the Telegram link if you, or you can tag us in the Twitter. We can get you those news, shared with the folks.
Okay. Sure. Cool.
Awesome.
Yeah.
Any other question, guys, for Sudhanshu?
Yeah, I think now we should give it to the next speaker. I have eaten up too much time.
No, not really. The plan is we are planning to postpone the next session anyway. So yeah, we can take another 5 minutes for questions and everything.
Then it's fine.
Charanya, Sudarshan. Hey, Sugendran.
Is Karthik?
You guys have any questions?
No.
Awesome. Then if at all there is no questions, probably we can wrap up the session, and then we'll catch up for the second session. Gopi session is being postponed. We will let you guys know when, and obviously nowhere. It's all going to be soon, but when. Okay, so before we wrap up, first of all, thank you so much once again, Sudhanshu, on giving up, taking your time and on this Saturday and coming here and helping us to learn a lot of interesting stuff.
Yeah,
and thanks a lot, really.
Yeah, if any of you have any questions, you can ask me on any medium you are connected with me. I usually answer most of this type of questions, like tech related, and I do this one-on-one mentorship as well, right? So you can book some slots and you can directly ask that this. Let's see if I do it today. I'll open few slots today as well.
Yeah, wonderful.
Okay, thanks everyone. Thanks for bearing me for 1 hour and 45 minutes.
Not at all. It's our pleasure, Sudhanshu.
Okay.
Yeah, cool. One final announcement, or like housekeeping announcement for the entire team or entire group. So guys, CFC is predominantly for us by us, so we always look forward to meet and talk about future road plans, or like what else you guys need from the platform or the community. And your feedbacks are always welcome. you can go ahead and share your feedback on the Telegram channel. Usually we do have the form. Dinesh usually send us a form where we can learn about the content of the speech and everything. But this time I will keep it open. You guys can go and share your feedback on the Telegram channel itself. And addition to that, we have a sponsor, JetBrains, who always give us 2 licenses on every month for the attendees and speakers. So if at all anybody, we usually go again, we usually run a raffle, but if in this time again the first 2 requests will be honored. So if at all anybody need JetBrains license, which you can use it against any of their tool suite. It could be WebStorm, it could be IntelliJ, or whatever you want, and Android Studio, or whatever you want for an year, you can use it for the Ultimate Edition. So these are 2 announcements I had, and wish you all a very happy weekend, and yeah, keep learning.
Yeah, thanks for having this meetup.
Yeah,
Sure.
cool. Bye guys.
Bye.
Bye, guys.